What's up? We're almost halfway through chapter 3, looking at section 3.4 today, which is using the quadratic formula. The quadratic formula has to be one of the most useful formulas of all time. Let's quickly write it out so we know what we're talking about. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. And that whole thing is divided by 2a. Okay, so what are b, a, c, and x referring to in this formula? The quadratic formula is used when you have a quadratic equation in standard form. And if you recall, standard form is ax squared plus bx plus c, where a is the coefficient on the x squared term, b is the coefficient on the x term, and c is the constant. Okay, and using the formula is as simple as just taking whatever those numbers are and plugging them in where you see those variables in the formula. But what are you actually solving for when you use the quadratic formula? What's this x equals part? Well, what you're solving for are the x-intercepts, also known as the roots of the quadratic function. So if we do a quick sketch of a quadratic function on a coordinate plane, there are three scenarios that can arise when you're finding the x-intercepts or the roots of a quadratic. The first one is that there are two roots, two real x-intercepts. Okay, so look at this parabola here that I just drew. There's an x-intercept here and an x-intercept here. And if you were to solve for those x-intercepts using factoring or completing the square or quadratic formula, you would get something like x equals, in this case, negative 1, 2, 3, 4, negative 4, and x equals negative 5, 6, 7. Okay, we'll pretend that's right on negative 7. Okay, so that's one case scenario. You can have two real x-intercepts or two real roots, meaning you actually see two x-intercepts on that quadratic. Okay, let's contrast that with another situation where you had a parabola that looks like this. Do you see any x-intercepts on this? No, right? Because the parabola is above the x-axis and it's going up. There is no time, there is no point at which this parabola will cross the x-axis. So there are no x-intercepts, there are no real roots on that quadratic function. And there's a third case scenario that's possible, and that is when you have something that looks like this, where there's only one x-intercept, and that x-intercept also happens to be the vertex of that parabola. So there's three possible scenarios. You can either have two x-intercepts, also known as two real roots. You can have no x-intercepts, also known as no real roots or zero real roots. Or you can have one x-intercept. That's when the vertex is also the x-intercept, and that would be one real root. Okay. So when you're using the quadratic formula, you're solving for these x-intercepts. Okay, so if you get, you can use it to figure out what the real roots are in this situation. You can use it to figure out what that x-intercept is, or you can use it to figure out that there are actually no real x-intercepts. And there's an important part of the quadratic formula called the discriminant. And the discriminant is the b squared minus 4ac part of the formula. Now, if b squared minus 4ac is greater than 0, that means that you have two real roots, which means that your parabola looks something like this, where it crosses the x-axis twice. If you have b squared minus 4ac is less than 0, that means you have no real roots. Okay, and that is the scenario where your parabola looks something like that, where it never crosses the x-axis. And if you have that, if b squared minus 4ac is equal to 0, then what do you have? You have one real root. And that is the scenario in which your vertex is also your x-intercept and it only touches the x-axis one time. Okay, now let's talk about something important. If you have no real roots, that means you actually have two imaginary roots. Okay, so you're going to have two imaginary roots. And we'll talk about an example what that means. All right, so let's go through and do a couple of practice problems. So here's our first function, f of x equals 2x squared minus 4x minus 1. Okay, so we want to solve for the x-intercepts, or the roots of this function. Now, we don't know how many roots this has, whether it has 2 real, 1 real, or no real roots. How can we figure that out? Let's apply the discriminant. Okay, so we know the discriminant is b squared minus 4ac. So in this case, my a is equal to 2, that's the number here. My b is equal to negative 4, that's the number here. And my c is equal to negative 1, my constant value. So applying the discriminant, I get that b squared minus 4ac would be negative 4 squared minus 4 times 2 times negative 1, which is 16. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8. 16 plus 8 is 24. Okay, great. So my discriminant in this case is positive. It's greater than 0. And if you look up here, if b squared minus 4ac is greater than 0, what happens? We have 2 real roots. Okay, so that means our parabola is going to cross the x-axis twice. So now we know that, let's actually go ahead and apply the formula. So now we're going to say x equals, and remember the quadratic formula is, I'll write it off here to the side, x equals negative b plus or minus the square root of b squared. You know what, I'm running out of space there. Let's just write it here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug everything in. So I get that x equals negative negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 1 all over 2a, 2 times 2. And we'll just start simplifying that. So that will give me negative 4 minus negative 4 is positive 4 plus or minus the square root of negative 4 squared is 16 plus 8 all over 4, which is 4 plus or minus the square root of 24 over 4, which is equal to 4 plus or minus 2 square root 6 over 4. I just simplified the square root of 24 to be 2 root 6. And that gives me 4 plus or minus, or sorry, not 4. We can now simplify everything by doing 2 plus or minus the square root of 6 all over 2. And there you have it. There's my two x-intercepts. The first one being 2 plus square root 6 over 2, comma 0. And the second one being 2 minus square root 6 over 2, comma 0. Okay, so remember this plus or minus means there are two separate equations. The first one is 2 plus root 6 over 2. The second one is 2 minus root 6 over 2. And these are actually x-intercepts, right? If you were to plug this into a calculator, which we can do now just for simplicity's sake, square root of 6 plus 2 divided by 2, you would get, this one becomes a decimal answer, 2.22. And the other one, 6 square root minus 2 divided by 2, negative 0.22. Okay, so these are actual x-intercepts. You can plot them on a coordinate plane, and these are the solutions to this quadratic function. These are the roots. Oftentimes you'll just leave it as the square root form. That's an exact answer, but sometimes you'll have to convert it to a decimal, in which you can just use a calculator. Okay, great. Let's look at our next example. Okay, let's look at our next example here. Let's use our discriminant test to figure out how many x-intercepts or how many real roots this quadratic has. Remember, the discriminant is b squared minus 4ac. So plugging that in, I'll have negative 6 squared minus 4 times negative 1 times negative 11, Our a is -1, that's the number in front of x squared. Our b is -6, that's the number in front of x. And our c is -11, that's our constant. -6 squared is 36. -4 times -1 is +4. +4 times -11 is -44. So that gives me -8. So my b squared minus 4ac is -8. And if you recall, if b squared minus 4ac is less than 0, there are no real roots. Okay, so that's the situation where the parabola never crosses the x-axis. So let's see what happens when we go ahead and plug this into the quadratic formula. Remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals -6 plus or minus the square root of -6 squared minus 4 times -1 times -11 all over 2 times -1. And we'll just simplify this. 6 plus or minus the square root of 36 minus 44 all over -2, which is 6 plus or minus the square root of -8 over -2. Now here's the part where it varies a little bit. What is the square root of -8? Okay, so the square root of -8 doesn't have a real answer. There are no two numbers that when you multiply them together, you get -8. Okay, so negatives under radicals bring us into the world of imaginary numbers. Okay, and we spoke about that a little bit earlier in this chapter. So the square root of -8 simplifies to 2i square root 2. Okay, square root of -8 simplifies to 2i root 2. Okay, and you can simplify this further by making this -3 plus or minus I root 2. Okay, I just divided each thing by -2. So notice our solutions here are imaginary. They are not real. There are two imaginary roots because our discriminant was negative. It was less than 0. And that's what's going to happen when your discriminant is negative. You're going to get two roots, but they're imaginary, not real. And what does that actually look like? That looks like a parabola that never crosses the x-axis. Okay, great. Let's look at our last example here before we go into a real-life word problem. Do our discriminant test, b squared minus 4ac. Okay, so -8 squared minus 4 times 1 times 16. -8 squared is 64. Minus 4 times 16 is 64. Boom, our discriminant is 0. And what happens when our discriminant is 0? Our discriminant is 0 means we have one real root, meaning our vertex is also our x-intercept. Okay, so we're only going to get one real root. Let's go ahead and use the quadratic formula. X equals -8 is +8, plus or minus the square root of -8 squared is 64, minus 4 times 1 times 16 is 64, all over 2 times 1 is 2, which gives me 8 plus or minus the square root of 0 over 2. Square root of 0 is just 0, so x equals 8 over 2, which is 4. Boom, only one answer, no plus or minus. Okay, because our discriminant was 0, that plus or minus portion gets canceled out, and we just have one real x-intercept, one real root. Remember, this is a coordinate point, so it would be 4, 0. That would be where our parabola touches the x-axis. This also happens to be the vertex of the parabola. Okay, that's what happens when you only have one real root. Great. All right, and then let's look at our real-world example now. The number A of tablet computers sold in millions can be modeled by the function A equals 4.5t squared plus 43.5t plus 17, where t represents the year after 2010. In what year did the tablet computer's sales reach 65 million? Okay. So all you have to do to solve this problem is figure out what goes where and then solve it, right? So if A represents the number of computers sold in millions, and we want to figure out what t is when that is 65 million, we would just replace A with 65, Why don't we replace it with 65 million? Because it's telling us that A is in millions, so we can just put 65 rather than 65 million. So it would be 65 is equal to 4.5 t squared plus 43.5 t plus 17. Okay? First step, whenever you want to use the quadratic formula, one of the sides has to equal 0. So you'll subtract 65 over, and you'll get 0 equals 4.5 t squared plus 43.5 t. 17 minus 65 is negative 48. And now you just plug everything into the quadratic formula. So t equals negative 43.5 plus or minus the square root of 43.5 squared minus 4 times 4.5 times negative 48 all over 2 times 4.5. Boom. And from here you just use a calculator. So let's go ahead and use a calculator. 43.5 squared is 1892.25. So t equals negative 43.5 plus or minus square root of 1892.25 minus 4 times 4.5 times 48 is going to actually be a positive 864, because a negative 4 times a negative 48 is a positive number. 2 times 4.5 is 9. And then we just keep simplifying that. So plus 1892.25, just simplifying under the radical now. I took the square root. I get t equals negative 43.5 plus or minus 52.5 all over 9. Now there's two answers here because we have a plus or a minus. One of them isn't going to make sense. Okay, so let's write out both equations. Negative 43.5 plus 52.5 over 9, and t equals negative 43.5 minus 52.5 over 9. I'm going to simplify both of these. So 43.5. This one you get 1. The bottom one you get negative 10.67. Okay, so remember, these are numbers of years. Does it make sense to have a negative number of years? No, it doesn't, right? So you're not going to go with the negative answer. That one doesn't make sense in this real life context. But t equals 1 does. And remember, t represents the number of years after the year 2000. So in the year 2001, tablet sales will reach 65 million.